Hey everyone, today we are going to look at multiplying a monomial times a polynomial. So a monomial is just a one-term kind of thing. For example, like this right here, 6x is a monomial. But the thing that happens is like you can have a monomial multiple times and now it's called a polynomial. So all of this is a polynomial. This would be considered our monomial, okay? We're multiplying this monomial times this polynomial, okay? So this is going to be a one-term kind of a deal, and your polynomial will be more than one. You can have polynomials kind of like the generic term. You can have, this is a monomial, it has one term. If you have two terms, like the example in number 1 down here, that is called a binomial. And then just like this example up here that I have already highlighted, this one right here is which one I'm talking about. It actually has 3 terms, so it's called a trinomial. So monomial, mono means 1, a binomial means 2, and a trinomial is 3, okay? So that is what we're doing, and that starts our lesson, and later we'll just keep adding to it. So what we're doing today is a lot like just distributive property. But we have to use our exponent rules that we learned in this last unit in order to do those properly, okay? So you can look at these examples here. It kind of shows you exactly what we would be doing. We would be doing distributive property. You're going to be multiplying that negative 3x squared to each term. But remember, now that it has an x squared times an x squared with exponent rules, those exponents actually add together, okay? Your numbers still multiply, but now if you notice, we have our exponents adding to each other with our exponent rules. So that's what we're going to have to pay attention to. And then a little bit later in the video, you're going to have sums where you actually have to do it kind of twice. There's one here and there's one here, and then you're going to combine your like terms together if we can, okay? If you notice, real quick before we get started, if you notice then this answer here in blue and this one here in blue, if you notice how the exponents are kind of going down and decreasing kind of order, you take your highest exponent and you want to write it first. So to the 4th power, we would write it first, and then to the 3rd, and then to the 2nd. And if we'd have more, we would keep writing it down in descending order, okay? Here, our highest exponent was a 3, and then we had x squared, and then we had an x. Remember, that's just to the 1. And if we had a number behind it, then it would follow because it does not have an exponent. So again, when we go to write these answers, just keep in mind that and how to write it. We want to write it with like our largest exponent first and then going down. All right, so let's get started. Let me scooch this down real quick so we can see our problems. Okay, so the first thing we're going to do is we're going to multiply this x times the terms on the inside. This is a polynomial, right? There's 2 of them, so it's really a binomial is what we're going to call it. So x times 5x. Well, this has a 1 in front of it. So 1 times 5 is still 5. X times x. Now, those are exponents. Remember, you have an exponent of 1 here, and you have an exponent of 1 here. So 1 plus 1 would give you 2. So x times 5x would give you 5x squared plus, now we have x times x squared. So x to the 1, and then that one has an exponent of 2, so we get x to the 3. And like I told you just before, we kind of want to write it where our exponent, the highest exponent comes first, and then your smaller exponent comes after. Now, are we going to count it wrong? No. Is it going to be written this way for like a multiple choice answer? Absolutely, it should be. And it just helps you be able to notice it a little bit more. All right, so let's look at this next example. So x times 4x squared. So remember that this x has a 1 for the exponent. We're going to be adding that to this exponent with the 2. So we end up with 4x to the 3rd power, 4x cubed. And now x times 3x. Okay, so I have 3x squared. Because remember, 1 plus 1 here is 2 for the x squared. And then x times 2. And that's just 2x, and we're done. That's it for this one. Okay, now we can do multiple variables. Like on this example for number 3, it has negative 2xy and then times our binomial. So we're still going to be multiplying. Okay, negative 2 times a 2 is negative 4. Now, if you notice, there's no x right over here in this term. So I'm just going to leave my x alone and bring it down. Okay, there's nothing to multiply it with. Now this y, however, this is a y to the first power, and so is this one. So 1 plus 1 would give you y squared, or y to the power of 2. All right, so now let me use a different color so you can kind of visually see it better. So negative 2xy times the second term in our binomial. So negative 2 times 4 is negative 8. And then I do have x's over here. So x to the 1, and this one has x squared. So if we add 1 plus 2, we get x cubed, or x to the third power. And again, just kind of like the last one, well, we don't have a y in this term. So we're just going to bring our y. Okay, we're bringing this y here down. Okay. Can we combine anything? No. Okay, so we can't combine anything. So that is our answer. I just used 2 colors to help you show it. So let's look at this number 4 example. So now when we multiply this monomial, negative 2g, we're actually going to be multiplying it towards what's called a trinomial. There's 3 terms in this parentheses. So let's get started. Same concept. Negative 2 stays negative 2. This is g to the first power, so 1 plus 2 would give us g to the third for our answer. And then for the next one, negative 2 times negative 2 will be a positive 4. And this has an exponent of 1, so 1 plus 1 would give you g squared. And the last term over here would be negative 2 times 2, so you get negative 4. And there's no g's or anything like that, so we just bring this g that's on the outside of our parentheses down. And there's your answer. Let's look at number 5. Let me change my color. So again, 3x times x to the 4th. So this is an x to the 1 power. So 1 plus 4 would give you 5 as an exponent. So 3x to the 5th. Multiply your next term. So 3 just comes back down because it's multiplying times 1. X to the 1, x to the third. So 3 plus 1 will give you to the 4th. And the last one, 3x times x squared. So we have 3, and then x to the 1, x squared, add them together, 1 plus 2, and it gives you 3. So try this next one on your own. Pause it, see if you get it right. All right, so hopefully you multiply negative 4x times x to the third. So you get negative 8 x to the 4th. Please remember, if it doesn't show an exponent, it is a 1. So 1 plus 3 was how we got x to the 4th. Next term. Negative 4 times negative 2 is a positive 8. Okay, if you got this wrong, please change it. And then 1 plus 1 will give you x squared. This is a 1 if it doesn't show it. And the last option, hopefully you got minus 12x. All right, so fix anything if you did get it wrong. If you got it right, great job. Let's move on to the next one. All right, so we just have some more examples for you down here, okay? I'm going to let you do number 7 and 8. If you have questions, you can get a hold of Mr. Jewell and I. Please look at number 9 now, though. So if you notice here, we have 2x squared y squared times this whole trinomial, okay? We do have x and y's in both of these first ones that we're going to multiply. So 3 times 2 gives you 6. X now becomes x to the third, and y becomes y to the third. Okay, remember both of these had 1 exponent, so 2 plus 1. That's how we got that. So now 2 times 2y. So 2 times 2 is 4. Our x squared, nothing multiplies with that, so we bring down our x squared that we started with. Y squared, oh, we do have something we can multiply, so now that becomes y to the third. And then the last option for our trinomial, 2 times 5 is 10. And x will add to be x to the third. And your y squared actually comes down because nothing multiplies with it. All right. And for a little bit more difficult, so now we're going to have the same kind of process, but we are going to combine like terms afterward. So I am going to do this first one first. So 6a times 2a is 12a squared. And 6a times b is minus 6ab. And then now we go with a whole new thing. So 2a is multiplying. So we get negative 8a because that's a negative 4. And a is going to be squared. And then 2a times 5b is 10ab. All right, so what can we combine together? Well, we can combine a squareds with a squareds. All right, so if we can combine a squared and a squared, so 12 minus 8 gives you 4a squared. Oh, let me change that color. It's kind of hard to see, isn't it? Good for highlighting, not for writing. So we have 4a squared. And then can I add together these? Yes, absolutely we can. It doesn't matter if you write it as AB or BA. They both have a power of 1, so we can't add them together. So 10 minus 6 would also give you 4. And be sure you write down AB. It doesn't matter. Usually it goes in alphabetical order if you wanted that bit of knowledge. 13. Okay, now we're multiplying times a trinomial. And then all of a sudden we have some more. So we will be combining like terms. 4r times 2r squared is 8r to the third. 4r times negative 3r is negative 12r squared. And then 4r times 5 is 20r. And then we get to do the second part. So I'm going to do that in a different color. 6r times 4r squared is 24r cubed, or r to the third power. 6 times 2 is 12. And then you get r squared because you add your r's. And 6r times 8 is plus 48r. Okay. Combine where we can. Let me go back to different colors here. I have r cubes, r to the third power, and I have another r to the third power. Let's see. Do I have r squared? Yes, I do. R squared will match up with this r squared. And then do I have regular r's? And we have regular r's. So these will come with this one here. So remember, you're grabbing that operation sign that is in front, okay, of your thing. So what is 8r cubed plus 24r cubed? You should get 32r cubed with a 3. Okay, so those are done. Clear those out here. Now you're onto the yellows. 12r squared minus 12r squared. Those just cancel each other out. That's 0. Don't write anything down. And then 20r plus 48r, we get 68r. And our answer. There is our answer right here. 32r cubed plus 68r. Now, if you want to try number 14, let me scroll down here so you can kind of see number 14. Pause the video, come back to us, and you can see if you got it right. So, welcome back. Hopefully you got 12n to the third power plus 4n squared and minus 16n. All right, that's for the first one. Now for this second little bit, we have minus n on the outside. So a minus n times 3 is minus 3n. And a minus n times a minus n, or a negative n times a negative n, is a positive n squared. So change it if you didn't do this, the right sign. Let me go back to my different colors. There's no other n cubed, so that's all by itself. Is there n squares? Yes. Here and here. And the last one, we have some regular old n's that we'll be combining. So remember, nothing combined with the 12n cubed, so we're just going to bring that down. Your n squareds are now actually 4 plus 1 gives you 5n squared. And then negative 16 and a negative 3 would give you negative 19n, or minus 19n. All right, I hope this helps. If you have questions, please get a hold of Mr. Jewell or myself, and have a lovely day.